Thank you, Mike, for the warm introduction. My name is Vicenti. I've been working at Facebook for the past 3 years. I joined in 2014 and was very honored and excited to be part of the team that open sourced React Native in 2015. And since then, I've been working a lot on React Native libraries like navigation, as Mike said, and also on React Native apps at Facebook. These days, I'm working on internal apps at Facebook, and it's given me some fun opportunities to work on some ambitious user experiences. So one of the things that I've been thinking about recently is a photo viewer. I've been hacking on this. And this is a GIF of it working on a $50 Android device and a 4-year-old iPhone. So performance is pretty critical for achieving what I'd like to think of as a delightful user experience. But it's a little bit better because this is actually a live demo. I'm performing this on an iPad, and I just put scroll views and scroll views because I have fun doing that. So let's take a look at the real photo viewer right now. Okay? It looks simple enough, right? It's just like this one photo that opens. There's a close button, but it's a little bit nicer to just take my finger and kind of swipe it away, swiping it down or swiping it up. Pretty easy, right? Well, it turns out that UI that I just realized I'm calling this beautiful UI. I'm not trying to be presumptuous, but UI that is really elegant and delightful often relies on really ugly hacks, and that can be pretty problematic sometimes. So, what are some of the hacks that went into this photo viewer? Well, there's one very specific hack in particular. We know of this as a shared element transition. A third element transition is what I like to call it, though, because there's really 3 elements in play. There's an inline photo here for our horizontal scroll view to swipe between other photos. But then here we're seeing a fake third image. And then as we go back into our original screen, this is just another normal horizontal scroll view. So that was a very specific hack, but I'd like to discuss some more general hacks that all of us can use today in our React Native applications. 3 practical hacks in particular. So let's take a look at what we already use to build our interactions, right? What are our animations and gesture libraries? Well, we all know and love the animated library, and we're probably also used to the touch responder system in React Native. Now, let's take a look at the animated library first, and at a simple example where we're just going to be fading something in, right? We've got this opacity with 0 value, right? And then what we can do is we can render a view and apply the opacity to it. Next, we can animate it open with an animated.timing. This is all pretty basic animation stuff if you're used to doing this stuff in React Native. So the real question is, how does this work, and is there any problem with the way that it currently works? Well, I'm going to introduce first a new character, the React Native thread. Now, she's the one who actually has to go and read our code and interpret it, all in her head. Now, that's great, but sometimes our code can be a little bit slow. Sometimes we're performing business logic or rendering large chunks of our application at once. The UI thread, or the main thread, is the one who puts stuff on the screen. She's kind of the adult of the situation. That's why she's got the little bow tie. She's able to do this at 60 frames per second because that's kind of standard for native applications. So how do they collaborate here? All right, well, the JavaScript thread will basically just say, in this case, we're going to create a new view that we're going to animate in. No problem. And then the JavaScript thread is incrementally going to say, every couple of milliseconds, change it to 0.01, change it to 0.02. Now, this is what happens when you use the animated library out of the box. Now, that's sometimes fine, but like I said, sometimes JavaScript is busy doing a bunch of other stuff. And this also really pollutes the communication channels between the different threads. So this seems pretty problematic. And it leads me to the first hack, which is to basically just delegate this work to the native thread. So we're just going to animate on the UI thread. It should be pretty easy, right? And a lot of you guys are probably saying, like, wait a second, this isn't a hack. This is just straightforward, right? She'll say create a view with opacity 0, no problem, and then animate it on a certain timing to 1. No problem. This is just use native driver. It's this awesome feature that we have in React Native, right? I'm sure some of you have already been playing with this. Now, it's extremely easy to use. All you do is you set use native driver at the place where you're driving the transition. So here we've got it on our animated timing, but it also works on animated spring, etc. And this works really great for things like opacity transforms, but it doesn't support all of the sorts of things that we're used to animating in React Native. It doesn't support flexbox. It doesn't support position values, any of the position values. It doesn't support things like image resize mode. But it does support transforms. So to understand why, we're going to need to introduce another character onto our scene. And this is the React Native thread. This is the guy who's got yoga in his head. He's like got the chi going on and knows how to put everything in the right place. So when JavaScript asks to create an image with a very specific position and resize mode, he'll go ahead and step in and tell the main thread to create the coordinates at very specific coordinates, or to create the view at very specific coordinates. And then the main thread is like, sure, no problem, I can create this thing at the coordinates, but she cannot animate these things at 60 frames per second because she doesn't really know what they mean. So now the JavaScript thread has to go and apply additional transforms on top of that the main thread can understand. She says, hey, well, forget about the layout that was already done in the past. You're just going to do the transform, where you're going to move the image up or you're going to move it down on a certain ease, etc. So this is why I consider the layout animation to be a little bit of a hack. Or sorry, not the layout animation, the use native driver to be a little bit of a hack, because we don't fully support all of these things yet, and it's really painful to do sometimes in the code. And you're like, sure, why is a transform so complicated in the code? You know, we just make it bigger, right? Well, if you saw that carefully, you'll notice that one of the things that isn't supported is image resize mode. Here we're using image resize mode contain, and here we're using image resize mode cover. So how the heck does that transition work? Well, it's kind of terrible actually, but it's a fun challenge to implement, because there's basically a view on the outside of the image that we are squishing. And as we squish the view, we squash the image. We basically do the opposite scaling effects from the view as we do on the image. And this is just to achieve something that looks relatively simple, like this shared element transition. So let's take a look at this code, and I hope your eyes glaze over a little bit because it's kind of ugly. We've got all this normal positioning logic. We're also controlling the opacity. And then we start to transform it. We translate it horizontally, and then vertically we've pre-computed that because it involves the touch. Next, we're going to control the scale, but we're also going to squish the view, which is going to help us with our different crop that we might have in the inline photo versus the opened photo. And then it's getting worse because now in the image that we render inside of the view, we have to do the opposite transform. So this is us sort of squashing the image. You can see it's 1 over, for the output range, it's 1 over the same way that we were squishing it before from the view. So if you thought that was bad, actually, wait till you see the math that we kind of have to do ahead of time in order to even compute that. So that's why I consider animating on the UI thread to be something of a hack right now, even though ideally it's just the right way of doing things. Okay, so let's go ahead and introduce our last character, and it's a really important character. It's the client, it's the great finger. And the great finger has very important expectations, because if the great finger is unhappy, then the user experience is not delightful, and our clients aren't happy. We're not happy. So how do we currently handle touch events? Well, we've got the gesture responder system, right? And we usually use pan responder on top of that. Now, for those of you who aren't already familiar, there are these hooks that look like this, right? They're props that we can put on view, callbacks that we put on view that tell the system when this view should own a touch, right? That's what it means to say should set. It's like saying, I want to own this touch. And then there's additional hooks for when the touch gets moved, released, or even taken away from you. And to understand why this is important, let's take a look at a super simple example, right? We've got a button inside of a scroll view here. And the button and the scroll view, they don't really know about each other. They both just follow the same rules of the responder system. So this can be a much more complicated case. But here, I'm going to start pressing the button, and it's highlighting, saying, yes, I'm now responding. And if I let go, I've pressed the button. But if I press the button and move, and my finger is still on the button, and I let go, the button doesn't press. And the reason why is because the responder has been taken by the button using the responder API, basically from the scroll view. It's actually a little bit more complicated because it's a scroll view, but we'll get into that a little later. So how does this really work? The native thread will notify everyone when a touch has started. And then the JavaScript thread is basically like, don't worry guys, I got this. She's already super busy doing business logic and all this rendering, but she's like, this should be no problem, right? All right, and then as additional touch events happen, the JavaScript thread goes and they have to communicate on this again. On a frame-by-frame basis, they need to go back and forth and communicate about what exactly is happening. So as you can imagine, this is not going to be a very productive room that these three are hanging out in. They're just chit-chattering about all this stuff back all day. So if only we had a way to sort of work around this interaction lifecycle. If only there were some techniques that we could use to manage this. So what exactly does the great finger expect? What does our client expect when they start touching? Well, at the beginning of the interaction, they're going to expect, well, actually, you'd be surprised. At the beginning of the interaction, there's a little bit of leeway that we have. We can have a delay at the beginning of the interaction of maybe 100 milliseconds. In some cases, in views where you have a double tap, we even need to wait 250 milliseconds-ish to even respond. So the user sometimes doesn't even notice delay at the beginning of an interaction. However, once the interaction has began, either a touch interaction or an animation, we need to be responding at 60 frames per second. We've only got 16 milliseconds between frame boundaries, and that can be pretty tricky in our room of different threads. So our client is going to expect smooth motion once the motion starts, because it's very easy for the client's eye to spot the frame drops. And then lastly, at the touch end, right? You'd think that the touch end wouldn't be that difficult, right? At the beginning of the touch, we had a little bit of leeway. Yeah, the middle was tough, but the end should be no problem. Well, it turns out the end is actually a bigger problem than during the middle of the touch, because we need to seamlessly transition from a touch to an animation. Because usually what you want in your gesture interactions is to have your touch carry through with the same velocity. So now we've got such little time. We have less than 16 milliseconds to go from a very smooth touch interface to animating forward with a fire and forget animation, which we could do on the UI thread. So what are the sort of ways that we can hack around this? Well, one of my ideas that I gave a good try was the main thread. When she reports that a touch moves, what if the JavaScript thread sort of, we're still going to use the responder system. But instead of using the responder system in the sort of naive way of deliberately setting the values one at a time, we're going to smooth it out in the same way that we did for the first hack. We're going to use native driver again, which is going to allow us to get a really smooth interaction as the touch starts moving. And this works. This does allow us to get a really smooth motion. But you'll notice that if you're playing around with this on iOS, all of a sudden it feels like Android. And you're like, whoa, what happened? It's that the latency is really bad. So even though it's visually very smooth, it's noticeable to the user, especially on iOS. Now, on Android, I think this might actually be a viable approach for low-end devices that can't really otherwise have smooth animations, and this is a little bit more expected. But I'm still kind of putting this hack on the table for now, because the latency is really bad on iOS. It doesn't feel good. So what other things can we do to work around the interaction lifecycle? There must be some other things we can do now that we know what the client expects. Well, we can utilize that initial perception delay. Like I said, we've got a little wiggle room when the touch starts. We've got 100 milliseconds to do stuff before the user is going to be like feeling that the app is unresponsive. So in the case of the photo viewer, this is really critical. We need to go and start measuring the photo. We need to go and start mounting the third element transition. All of this takes time. We need to do additional calculations. So utilizing the initial perception delay is a real great way to hack around the client's expectations. The other thing we can do is not even wait for them to press up. When they're pressing down is when we can go ahead and start this work. And then what we'll do is if they wind up pressing, then that'll be great. We'll have actually sped up this whole interaction. But if they wind up swiping instead, then we can just throw that away. So we can start the animation work when they press down. And lastly, we can use this API that React Native provides called Interaction Manager. And this is kind of like a global lock for performance-intensive work, where you can say that, hey, I'm now doing something that requires a very high frame rate. And then everything else in JavaScript now needs to consult with Interaction Manager to make sure that it doesn't do anything slow. Now, this is another hack, because this is kind of like this extra layer that we've added on top of the language to deal with the fact that JavaScript can be a little bit finicky sometimes when all sorts of different things are going on. So that's not perfect, but this does work to some extent. This is what we used in the Navigator library before we had use native driver, which is what we use in the newer navigation libraries. So these are a few of the ways that we can hack around the interaction lifecycle. But that doesn't really answer how this photo viewer works, right? As I'm swiping, I know you can't tell, but this is very low latency. My finger knows it. I'm the client right now, and I feel great. So how does this work? Well, what we really want is we really want the JavaScript thread to be saying that, hey, as the user swipes, these are the transforms that we're going to do. and we want the native thread to comply. But unfortunately, right now, the responder system is entirely owned by JavaScript. This is a kind of unideal state. So there's actually no way in the existing world of React Native, or sorry, there's no way in React Native core right now to achieve this exact interface, where the JavaScript thread can declaratively say that, hey, I want you to behave in this way when touches happen. The good news is the industry has been working to address this problem. So earlier this year at ReactConf, Tal Cole with Wix announced React Native Interactable. And this is extremely exciting. This is a full-fledged declarative physics library that runs on the native thread. These are awesome things. It basically is UI kit dynamics, but it's been re-implemented now to run on Android 2. It's this pretty awesome system that allows you to very declaratively describe how you want things to behave in a sort of physical way, where there's friction over here, or it just slides over there, or there's a stopping point that your view is going to bounce against. So React Native Interactable is extremely exciting. And I'm also extremely excited about React Native Gesture Handler that Christoph Magiera, former React Core team member, he talked about this at React Amsterdam a few months ago. I highly recommend this talk. And what this does is it's basically a full-fledged gesture system that runs on the main thread, but also integrates nicely with the pan responder system. It integrates nicely with the responder systems that we're already using and the native views. So this is extremely exciting. Now, I don't really have a slide for this because I was just talking with Tal this morning. Hi, Tal. But basically, it's extremely exciting that these libraries are now going to be playing nicely together as we move forward. So the industry is still working on a more mature solution for this, but it seems like a very likely possibility is that React Native Gesture Handler will offer the interaction with the existing responder system, and we'll be able to use Interactable on top of it to get this great physics API that we can use on the main thread. So wait a second. I jumped to talking to the solutions. These are awesome solutions, but they're not really ready in core React Native today. I told you that I would have 3 hacks for you that you can use today. So what is the hack? Well, I told you guys, this whole thing is scroll views. I'm a big fan of scroll views. Dog, I love putting scroll views in scroll views. So that's what we did here. So what we can do is we can abuse the scroll view as a general purpose main thread gesture recognizer view. So how does that work? Basically, rather than the JavaScript thread telling the main thread that, hey, as a touch happens, or instead of the JavaScript thread talking about responders, the JavaScript thread is just going to say that, hey, as this scroll position changes, these are the transforms that we're going to do. And this is how it works. We're going to go ahead and take a look at a simple example here. This is about as simple as it gets, which is, by the way, the only hack that I can show you all the code for. So that means this is actually the simplest hack yet. The only reason it's hacky is because the scroll view is not meant for this, and also the scroll view has very specific behaviors. So here's what we're going to do. Is we've got a scroll value, and we're going to render that with an animated scroll view. And we're going to configure the scroll view using this animated.event destructuring syntax. We're going to say that, hey, as the content offset y changes, feed that value into this .scrollY, and definitely use native driver. And then we're going to go ahead and render the animated view and have it transform in the opposite direction. So the effect that this is actually going to achieve is the view will be moving in the opposite direction as the scroll view, and it will stay in place always. So if you have a sticky header in your application that's kind of jumping around, look into this approach, because this was kind of meant for sticky headers, and that's the actual good purpose for this, but we're going to go ahead and hack it. So let's take a look a little bit about the behavior. Like I said, it feels kind of like a scroll view. We're kind of constrained in the way that the gesture gets recognized. So I'm going to go ahead and let go here. I don't have any control about what happens when I let go. That's basically just because I have a scroll view on the outside of this inside scroll view. And the outside scroll view has 3 pages. It's got paging enabled, and we start on the center page. And I can go down to that page, and it has that one transition, or I can go up to this page. Has this other effect. So we're very constrained in the way that it works, but it also feels a lot like a scroll view in good ways and in bad. So I can go ahead and swipe here, just like with the horizontal scroll view. Like if I swipe a little bit in one direction and then follow through in the other direction, it follows through. Likewise, I can swipe up a little bit and then follow through in the opposite direction. Now, this happens to feel great in the case of the photo viewer, but this might not feel great in every case. I've played with using the scroll views with, of course, a Tinder interface. You've got to try that. And then you can also use scroll views for things like a drawer that you're going to slide in from the side. But there are some sort of constraints, and we don't get that much flexibility about how it works. But that is my favorite hack by far, because it's a pretty clean hack, and it's basically just abusing it in a slightly different way. It's not quite as dirty to code as the other hacks. Cool. So now that we understand the way that our threads communicate with each other, and now that we understand what our client expects when she touches the screen and starts to interact, we can go ahead and really understand how to perform delightful interactions. So the 3 hacks that we talked about today are to, 1, delegate the fire and forget animations to the UI thread, because she can just go ahead and do these at 60 frames per second. It's kind of unpleasant, though, because we have to write transforms code instead of using Flexbox and layout and all of that. The second hack is to pay attention to the expectations of the client, to make sure that the interaction lifecycle gets respected, such that once the interaction starts, which can be delayed by a little bit, once the interaction starts, we're constantly performing at 60 frames per second with 16 millisecond frame boundaries. Oops. And then lastly, we really want to use scroll view for gesture handling. That's just my favorite hack, because it allows us to use a main thread gesture recognizer today in our existing apps. We don't need to wait for React Native Interactable and Gesture Handler to arrive. So the question is, should we feel bad about this, right? Like, here I am, like professing my love for these hacks to you guys. Like, do you guys hate me for that, or is this okay? I mean, personally, I think hacks can be amazing. We should have pride in our hacks and really own them. And I'm using the word own very deliberately because there's a cost to ownership, right? Hacks are really unpleasant to maintain. As developers, we'd love to work on beautiful code that's as beautiful as the applications we're building, right? Unfortunately, hacks really take that away from us. But we can be proud of them because they deliver delightful interactions in cases where we might not otherwise be able to do them. And the other thing is that it helps inform the evolution of library development. If not for hacks like these, then we might not even be pushing for things like React Native Interactable or Gesture Handler, which are the real solutions to these problems. So I guess my message to you all is pretty simple. When you have to ask yourselves, should I be writing ugly code in the name of delivering beautiful user interactions? The answer is yes. Go forth and hack with pride.